Continuation of the reading of the book The New Map, Chapter 46, The Changing Mix. Reading the map was more straightforward before the coronavirus. One could ascertain directions and trends, although also noting often strong disagreement among the readers about the speed and extent. But as the result of the pandemic, an uncharted chasm has suddenly appeared on the map, which the world is now struggling to work its way around. Yet one can see some of the features of the new topography. Some trends will remain the same, some will be accelerated, some will change direction, and some will simply play out over time. On the premise that the coronavirus is a finite crisis, whether there are further waves of infection or not, and that science and medicine provide timely answers, what can we now see for the future of energy, trying to look beyond the global economy's recovery period? Well, in the years ahead, CO2 and GHG policies will bring continuing changes in how energy is produced, transported, and consumed. In strategies and investment, in technologies and infrastructure, and in relations among countries. Established companies will be tested for their adaptability. New entrants will have to prove their business models. Partnerships and competition will characterize the relationships among different kinds of companies. Energy security concerns will expand to the supply chains, supporting low-carbon industries, and to the minerals on which renewable energy technologies depend. Climate change is global, but nations will respond in different ways, depending on their own particular situations. Developed countries will have more flexibility. Developing countries will struggle to balance between low carbon and the need for low-cost solutions to promote economic growth, especially in an aftermath of the coronavirus crisis. And aspirations will come up again, an ineluctable reality. Today's energy system, which is more than 80% based on oil, natural gas, and coal, with a huge embedded investment in infrastructure and supply chains, all of which will be required to meet the energy needed during the recovery period and get back on the economic growth track. The scale of the system is enormous and cannot change overnight. So far, the energy transition has actually been, in the words of energy strategist Atul Arya, the phase of energy addition. Wind and solar have been increasing, but they were doing so atop conventional energy, which was also growing. In the United States, no new coal plants are being built, and the number of operating plants is declining. Worldwide, the picture is different. Asia is on track to sustainability increase its coal consumption with the construction of more efficient coal-powered plants. Coal may be a declining share, but it is still a mainstay for the world's two largest countries, China and India. Important not only for energy, but also for employment and energy security. As observed before, coal still represents almost 6% of China's total energy supply. China is not going to abandon coal, said a senior official. China is different from Europe. China is a developing country. We need to maintain our consumption, but it also means good to use of coal, cleaner coal, and China's new 5-year plan, 2021-2025, puts a renewed emphasis on coal for energy security and calls for safe and green coal mining and clean and efficient coal-fired plants. A little more than a decade ago, some predicted that peak oil and end of oil was near and the world would run out of petroleum. The argument has now flipped over to peak demand. When will oil consumption hit the high points and begin to decline? Ever since that first oil flowed out of Colonel Drake's well in 1859, the world's demand for oil has steadily risen, though with occasional dips due to recessions, depressions, and price spikes. The great exception, of course, was when the government-mandated lockdowns shut down much of the world economy in 2020, and demand collapsed in a way that has never happened before. But for trends, we can use 2019, when global oil consumption was more than 30% higher than it had been in the 2000s. Yet, while consumption has continued to grow, the map of consumption has changed. For decades, demand was concentrated in the industrial nations of North America, Western Europe, Japan, and Australia. The developing world's share was relatively small. No longer, since 2013, oil consumption in the emerging markets and the other developing countries has been greater than in traditional industrial countries. In between 2000 and 2019, consumption rose a little in the United States, declined a little in Europe, and is in aging in Japan dropped a lot. Over that same time period, almost all the growth in oil demands has been in the developing world. China is now the world's second largest consumer, after the United States, India being the third. And it is in emerging markets where the future growth will continue. Of course, there was always the understanding that at some point global demand would stop increasing, but peak demand was something considered to be far off into the future. The reason was simple. Rising population and rising incomes would continue to push up demand. The number of autos would increase around the world, and of ownership in the developing world caught up with the developed world. For now, the gap remains very large. In 2018, there were 1,867 cars for every 1,000 people in the United States, 520 in the European Union. Compare what to the 339 in Russia, the 208 in Brazil, and 160 in China, and just 37 in India. In other words, the world's auto population will grow substantially, and incomes rise, and the number of people increases from the today 7.8 billion to 9.5 or 10 billion people in the world. In rivalry, IHS market planning scenario, the world's auto fleet grows from its current level of just over 1.4 billion to over 2 billion by 2050. Of that 2 billion, about 610 million are electric vehicles, almost a third of the total. The fleet simply does not turn over quickly. Annual new car sales represent only about 6 to 7% of the total fleet. Most of the fleet is composed of vehicles that have been purchased over the preceding dozen years. In the United States, cars on average remain on the road for 11.8 years, but EVs catch up. By 2050, in this scenario, some 51% of total new car sales are EVs. This is substantial change, but not as fast as some may expect. In light of economic difficulties and job losses from the 2020 shutdown, regulators may ease up on the steep requirements for reductions in carbon emissions that are pushing a shift to electric cars. Indeed, the world would actually end up with almost the same number of oil-powered cars on the road in 2050 as today, but they will be more fuel efficient. People may drive more miles in vehicles that require gasoline, but the amount used for each mile goes down. That in turn may reduce the incentive to switch away from the gasoline-fueled vehicle to electrical. In a more radical scenario around auto tech, the number of kinds of cars will change more rapidly, as they would with stringent climate regulations and larger incentives. Electric cars are not the end of the oil era. It is in the way that Faith Byrne, executive director in the International Energy Agency, puts it. Even if every other car sold in the world from now on were electric, he adds, oil demand would still grow. Cars and light trucks, SUVs, and pickups, as pointed out earlier, constitute 35% of the world oil demand, cars alone about 20%, and the rest of transportation consumption goes into heavy trucks, ships, trains, and airplanes. And the global fleet of civilian airlines, while more efficient, was expected to double by 2040. That may now be pushed out of the few years for the slower growth in the passenger level. Nevertheless, demand will return. Over 80% of the world's people have never been in an airplane. Flight shaming may be a social mode in Sweden, population 10 million, but China, population 1.4 billion, is building 8 new airports a year. One of the hardest problems is to find alternatives to jet fuel aside from biofuels, the volumes of which are small, and even if there were an obvious solution or one on the horizon, it would take a long time to have an impact owing to the lifespan of the existing fleet and the time to design new planes, get them certified, and then out into the fleet of airlines. Heavy trucks, because of their weight, require the energy density of oil in order to propel their loads along the highway, although in China LNG is also being used. Oil and natural gas are also the feedstock for petrochemicals, from which chemicals and plastics are made. A growing movement focused on limiting the use of plastic straws and the single-use plastic bags, especially owing the ocean pollution and the debris washing on the beaches in Washington, D.C. Straw cups hand out fines to restaurants that covertly use plastic straws, which are now banned. Recyclability to replace single-use plastics has become a priority. This is seen as part of a circular economy, where products are reused, recycled, and remade at the end of their lives, instead of going into landfills. But the plastic waste problem is largely not in the developed world. The United States generates less than 1% of the plastic waste in oceans. About 90% of river-sourced plastic pollution in the oceans comes from uncontrolled dumping into 10 rivers in Asia and Africa, which is, if properly managed, could dramatically reduce the wastage. Plastic bags and straws may be the most visible use of plastics, but they constitute less than 2% of the plastics. Moreover, the coronavirus crisis did demonstrate a health advantage of plastic bags over reused cloth shopping bags. The omnipresence and versatility of plastics made them a building block on the modern world. They are used in everything from making airplanes lighter and thus more fuel efficient and manufacturing electric cars to auto dashboards and safety glass in windshields and lenses. The bulletproof vests, the carpets, housewares, pantyhouses, clothes, and shoes, to packing yogurt containers and keeping food fresh, and thus preventing disease. They are used for water pipes, eliminating metal piping that rusts, and in solar panel and wind towels and blades, and in the casing of cell phones. They also are embedded in the health system. Petroleum products are intrinsic to modern healthcare. In the way an article in the American Journal of Public Health put it, plastics are central to the antiseptic model of the modern healthcare. Look at a hospital operating room. Gloves, tubing, the bags of intravenous liquids, instruments, and the tools that insert stents into ailing heart patients. Moreover, 90%, 95, 99% of pharmaceutical feedstocks and reagents are derived from petrochemicals. As for the N95 face masks that became the emblem of the coronavirus epidemic, they are made with petrochemicals. Petrochemical demand rises faster than GDP growth, sometimes twice as fast, and that means rising demand in the sector will offset the slack elsewhere. So, when will oil demand reach its peak? IHS Markit's rivalry scenario, which is planning case, point out to the mid-2030s, and in an alternative anatomy scenario, metal piping that rust. Just a moment. I got stuck. Continuation comes in the next video. Bye bye.